Okay, so today we're going to start solving by substitution. So what this means is that we will be, we have two different methods for substitution. We have one that's called setting equal, and the other one is just substitution. Setting equal is the one we're going to start with because it's the most similar to what we've already done. So we're going to start by looking at these two situations. We have a situation with Daniela, who charges $3 an hour to babysit kids, and Victoria, who charges $2 an hour plus a one-time registration fee. So really quick, let's take a slight detour and let's talk about something. So let's say I have 2 plus 6. What does that equal? Hopefully you're all saying 8. Yay! And then what about 3 plus 5? What does that equal? Well, that also equals 8. So, if both of these equal 8, shouldn't I be able to say 2 plus 6 equals 3 plus 5? Is that a true statement? Well, yeah, because if this is 8 and that is 8, it's true if I make them equal, okay? And this is the basic principle we're going to use when we set equal, okay? So let's look at an example, okay? First of all, we see Daniela. Daniela charges $3 an hour to babysit kids in Christina's neighborhood. She requires no registration fee. So remember, when I look at my variables, this is what's going to tell me, this per statement, the rate statement is going to tell me what my variables are, okay? So I have dollars per hour. I have y per x. In this case, I have, so h is the hours, which is my x variable. So I have number of hours. C is going to be my output variable because I work some number of hours and I get money. So C is going to be the total charge. Okay, so if I wrote an equation for this situation right here, I'd say, I'm sorry, I would not say y. I would say C equals 3H. So the charge is $3 per hour. Okay, now if I look over here, I have another person. This is Daniela, but now I have Victoria. Victoria also babysits. She charges $2 per hour to babysit kids. She also requires a one-time fee of $6. Okay, so in this case, I still have H being, or in this case, C per H. My H is still the number of hours. And my C is still the total charge. Okay, so that's the reason why this is considered to be a system, because I have two situations, I have two equations, and two sets, but the variables are the same in these two situations. My equation for this one is C equals 2H plus 6. The cost is $2 per hour plus a $6 fee. Okay? These two equations, in these two equations, the C and the H both represent the same thing, and that's what makes this a system. If the variables are both equal, then I can use those variables to solve the problem. In this case, since I have two variables, I'm trying to figure out what they're worth. I have to have two equations to solve it. If I was missing three variables, I would need three equations to solve. Okay? So let's take a look. Let's start off by looking at these equations on our coordinate plane. Okay? So let's remember, Daniela is C equals 3H. Victoria is C equals 2H plus 6. Okay? So I'm going to start by plotting these points. Well, Daniela, if you don't babysit any hours, she doesn't charge you. Shouldn't charge you any money. 1 hour is going to cost $3. 2 hours is going to cost 6. 3 hours is going to cost 9. 4 is 12. 5 is 15. 6 is 18. And we'll just go ahead and put a spot up there at 20. I'm going to use my ruler to connect these, but you'll notice that I made big dots on the line so that I could still see where the values were. Okay? Okay, so this is C equals 3H, or Daniela. Okay? Now, let's look at Victoria. Victoria starts at 6, and she charges $2 an hour. Now, notice, where they crossed, I put an X. Okay? What does where they cross mean? Hoping that what you're all saying right now is that that means that that is the intersection. and the intersection is the solution. So I can see that right here, they are the same. Okay? Hey, look at that. For what number of hours are each babysitter the same? Well, if I look at 6 hours, they're the same. And what do they both cost at 6 hours? They both cost $18 for both. Okay, and that's the point of a system, is where are they the same? Well, both ladies charge $18 for 6 hours of babysitting. Okay, so when is Daniela cheaper? Well, Daniela is this first line. So it's 0, 1, 2, 3, 4, 5, or anywhere from 0 to 5 hours. Okay, now Victoria, after 7 hours, 7 or greater, she becomes the better price. Obviously to a reasonable value, because like she ain't gonna babysit for like 300 hours. If she is, that's a whole nother job. Okay, so up to a reasonable number of hours. So let's take a little bit closer look. Let's go to page 2, and now we're going to compare this with what we would have done yesterday in our calculators. Okay, so we'll go into y equals. We'll put our two equations in. Okay, so I have y equals 3x, y equals 2x plus 6. And let's look at our tables. Okay, so I'm not going to write this table down because I've got it in my calculator. Okay, but if you want to, you can write them down, but you don't have to because we have it here. So I'm seeing the same exact numbers that I had before. I'm seeing them right now in my table. I'm sorry, I have to sneeze. It'll happen eventually. Okay, so y1 is Daniela, y2 is Victoria, and the same values I applied. So for 0 hours was 0, 1 was 3, 2 was 6, all the way up to 15. 18 was where they were the same. Daniela was cheaper up until from 0 to 5 hours. Victoria was cheaper for 7 and more. And they were the same at 18. Again, this is the same stuff that we saw before. Now here's where we're going to do something different. This is the algebraic method for solving a system. So we've done the table, we've done the graph. Now we're going to do the algebra. Okay, now we're going to do this by solving the equation. Okay, so remember on the first page here, remember over here we said if 2 plus 6 equals 8, if 3 plus 5 equals 8, then I could say that those two are equal to each other. Well, I'm going to do the same thing here. Okay, if I want to know when Daniela is equal to Victoria, then I'm going to write those two equations and set them equal. Okay, so I want to know when 3h is equal to 2h plus 6 because I want to know how many hours will it take for their costs to be the same. So then I just solve this. This is an equation. This is a variable with an equation with variables on both sides of the equal sign. I subtract 2h from both sides. This zeroes out, and I have h equals 6. Oh, okay. Well, in 6 hours, they're going to be equal to each other. Well, what are they when they're equal? Well, the way I would do that is I can tell from looking at my calculator table here, that at 6 hours, they both equal 18. Just looking at the calculator, I can see that that's 18 hours. But again, solving algebraically, what I'm going to do is I'm going to take one of the equations. Let's say I take Daniela's equation. So Daniela is C equals 3H. Well, I know the hours are 6, so cost equals $3 per hour for 6 hours. 3 times 6 is 18, which is exactly what I found in the calculator, which is exactly what I saw in the graph. I can also see the same exact thing with Victoria. Okay, C equals 2H plus 6, which is 2 times 6 plus 6, which is 12 plus 6, and 12 plus 6 is 18. I get the same thing for both, which means that at 6 hours, both babysitters charge $18. So that's this situation. So that's how we're going to solve these problems. All right, let's try a couple of examples here and we'll see what happens. All right, so let's take a look at this first example. The first example says y equals x plus 2, y equals 3x plus 8. So I can do setting equal because I have two equations that both equal the same thing. I have two things that equal 8, so they both equal each other. I mean, not 8, but you kind of get what I'm getting at from the first page. Okay, so if y equals x plus 2 and y equals 3x plus 8, then x plus 2 equals 3x plus 8 because they're both equal. I can set them equal to each other because they equal the same thing. So I'm just going to start solving. I'm going to subtract 3x from both sides, and I get negative 2x plus 2 equals 8. I subtract 2 from both sides. I get negative 2x equals 6. X equals negative 3. Okay, so I think x is negative 3. Well, I'm going to start by checking the first equation and see, does x equal 3? Okay, well, if x equals 3, what's y? So y equals x plus 2, negative 3 plus 2. Negative 3 plus 2 is negative 1. Okay? So I think that my solution, which has to be an ordered pair, I think my solution is negative 3, negative 1. I'm going to confirm that using this last equation. So I'm going to say y equals 3x plus 8. Well, let's see. If I plug in a negative 3 here, do I get out a negative 1? Well, y equals 3 times negative 3 plus 8, which is negative 9 plus 8, which is negative 1. Hey, I got the same thing. So that means that this system, the solution to this system, is the x, y coordinate of negative 3, negative 1. And that's how I'm going to solve that problem. I want you to take a minute and I want you to solve problem 11. I'm going to come back on and show you my work, talk you through it, and see if you got the same thing that I did. Okay, so I have y equals negative 3x minus 6 and y equals x minus 4. If they both equal x, if they both equal y, then they both equal each other, so I can set them equal. Negative 3x minus 6 equals x minus 4. That's 1x. So I'm going to subtract 1x from both sides. I get negative 4x, minus 6 equals negative 4. I'm going to add 6 to both sides. I get negative 4x equals 2. When I divide both sides by negative 4, I get x equals negative 0.5. Okay? How many of you freaked out a little bit when you saw that? I kind of did a little bit too the first time I did it, so I'm not surprised at all about that. Okay? Now we're going to take, now that we think we have x equals negative 0.5 as our answer, let's go ahead and substitute back in and see if we're right. Y equals negative 3x minus 6, which means y equals negative 3 times negative 0.5 minus 6, which means negative 3 times negative 0.5, I'm just going to use my shovel here, negative 3 times negative 0.5 is 1.5 minus 6, so y equals negative 4.5. Okay, again, I'm freaking out a little bit, decimals kind of weird me out, but I'm going to check. I have my last example, I'm going to check. So, y equals x minus 4, so y is negative 4.5, should equal negative 0.5 minus 4. Negative 0.5 minus 4 is, negative 4.5. So that's true. Even though it looked weird, it was right. So my answer is negative 0.5, negative 4.5. That is the solution to this system. Okay, let's try another one. Okay, so this one you should notice right away. You should be, and a lot of you, if you were looking at this, you go, if I already know the answer, do I have to do this? Yeah, you have to do it because we're practicing the process, not knowing the answer, although obviously knowing the answer is our ultimate goal. Whatever, you understand what I'm trying to say. Okay, so even though we know, many of you are probably immediately seeing, hey, these two things have the same slope. That means there's no solution. But we're going to prove mathematically and see mathematically what it looks like when something has no solution. I want you to know what that looks like, okay? So, since these are both equal to y, that means I can set them both equal to each other. So I have 5x minus 8 equals 5x plus 3. I'm going to get all my x's on one side, so I'm going to subtract 5x from both sides. I get negative 8 equals 3. Does negative 8 equal 3? No, it does not. Therefore, I have no solution. So when I get number equals number and it's false, false tells me I have no solution. Okay? Now, I think you can kind of assume something's weird going up here because it's asking me how many solutions it's got, and I've already told you that if it's got one solution, the answer is an ordered pair. So let's talk about this one. Can I immediately set these two equal to each other? I'm hoping that what you're saying is no, because they're not equal. 2y and y are not equal. So before I can set these two equations equal, I have to transform them somehow. I either need to divide this one by 2 to figure out what 1y is, or I got to divide them by 2. That's period. That's it. That's the only way I can. So I'm going to take 2y equals 6x plus 8, and I'm going to divide everything by 2 so that I have 1y. Well, okay. Well, that turned into y equals 3x plus 4. Well, those are the same line, so I have infinite solutions. But yes, we want to prove it to ourselves mathematically. So if they both equal y, then they both equal each other. 3x plus 4 equals 3x plus 4. And you're thinking, well, yeah, it does. They're the same thing. Okay, we're going to subtract 3x from both sides. They both zero out, and I get 4 equals 4. Does 4 equal 4? Yes. That means I have infinite solutions. So when I get a true statement, I have infinite solutions. When I get a false statement, I have no solutions. Okay? All right, let's take a look at these last two examples. All right, so if I look at these last two examples, we're not going to do this one. I'm going to cut you loose to do your homework a little bit early, but I do want to look at this one because for this one, this is going to show you the process you need to go through if you want to solve a system. Okay, so Joe has $20 in his bank account. He has decided to deposit $5 each week into his account. Jody has $5 in her account and has decided to deposit $10 each week. In how many weeks will Joe and Jody have the same amount of money in their accounts? Okay, so first of all, I need to figure out what my variables are. I have an x and a y. I wouldn't use an x and a y, but that's the variables they want us to use, so those are the variables we're going to use. So I'm going to look for a rate. I see $5 each week. I see $10 each week. But what I see is dollars each week, okay? And that means y each x. So x is the number of weeks. Y is the total dollars. Okay? So remember, my rate is going to tell me what my variables are. Okay? Now, they say, in how many weeks will Joe and Jody have the same amount of money? So I want Joe to equal Jody. So I'm going to write an equation for Joe. Joe has $20 in his bank account. So my first equation is y equals 20 plus 5x, because he's depositing 5 a week. Jody is y equals $5, sorry about that, I got ahead of myself, plus $10 each week. Okay, so I have these two equations, and because I want Joe to equal Jody, I'm going to say 20 plus 5x equals 5 plus 10x. And now I'm going to solve this problem. I'm going to subtract 10x from both sides, and I get 20 minus 5x equals 5. I'm going to subtract 20 from both sides. I get negative 5x equals negative 15. Divide both sides by negative 5, and I get x equals 3. So in 3 weeks, they'll have the same amount of money. Well, I want to know how much money that is. So I'm going to go to one of these equations, and I'm going to substitute it in. So I have y equals 20 plus 5x, 20 plus 5 times 3, which is 20 plus 15, which means that in 3 weeks, Joe's going to have $35. Let's see if Jody's going to have the same amount in 3 weeks. Okay, so let's try that. Well, Jody says y equals 5 plus 10x. 5 plus 10 times 3 is 5 plus 30, which is 35. In 3 weeks, they both have $35. In 3 weeks, Joe and Jody will each have $35. And this is what the answer to an equation with a word problem should look like. It should look like that because when they give me a real world situation, I have to explain what that means. If all they gave over these equations, I could write 335 as my solution. But they gave me a situation to go with it, so I have to explain what that situation means. Okay? So you're going to get started on your homework. You have whatever time is left in the period to work on it. We will grade it tomorrow. That's all.